Section 7.1, Square Roots. When a number is multiplied by itself, we say that the number is squared. If we can find a number that was squared in order to produce some value, say a, we call that first number a square root of a. Every positive number has two square roots, and 0 has only itself as a square root. Negative numbers do not have real number square roots. However, they do have non-real square roots. We'll look at those later when we talk about complex number system. In this first example, it's asking us to find the square roots of 121. Whenever we look for solving a problem similar to this, we're asking ourselves what number times itself gives us 121. And if we check, we find that not only 11 times itself gives us 121 because 11 squared equals 121, but also negative 11 times itself, in other words squared, is equal to 121. So the square roots of 121 are 11 and negative 11. Whenever we refer to the square root of a number, we mean the non-negative square root of the number. This is also called the principal square root of the number. So here they're asking us just to simplify. We're looking for the principal square root, which is the non-negative. What times what gives us 25? Well, that would be 5. The square root of 9 64s, since 3 squared, or 3 times 3 is 9, and since 8 times 8 is 64, the square root would be 3 over 8 would be the square root. But then they're asking us to take the opposite of that, so we would answer a negative 3/8 for the solution or simplification of that radical. In this next example, they're asking us for first the square root of 81. The principal square root is always a non-negative number. What times what gives us 81? That would be a 9. And then they're asking us to take the opposite of that. So negative 9 would be our simplification of this example. And the last one here, the square root of 0.16, what number times itself gives us 0.16. The principal square root would be the positive, which turns out to be 0.4, because 0.4 times 0.4 is 0.16. When a radicand, and the radicand is the quantity underneath the radical, is the square of a variable or variable expression, absolute value signs are needed when simplifying. We use absolute value signs unless we know that the expression being squared is non-negative. This ensures that our result is never negative. And the instructions here are telling us assume the variables can be any number, so use absolute values when necessary. So they're asking us to simplify this radical, 36x squared. What times what gives us 36? The principal radical or root would be 6. Try that again. I'm writing 36 again. Would be 6. And what times what gives you x squared? Well, that would be x. And to ensure that we have the principal root, we would put absolute values because we want a non-negative square root. In the next one, you might think negative 4, but if you simplify this expression following your order of operations, negative 4a squared is negative 4a times negative 4a is 16a to the second. And when we are looking for the square root, we always want the non-negative square root of that number. Square root of 16, as we see, is the 4, and of a squared would be a. And to ensure again, that we have the principal square root, we'll include absolute values around the variable. So 4 times the absolute value of a. This next has the radical or the square root of x squared minus 6x plus 9. If we factor that trinomial, this turns out to be an x minus 3 quantity squared. What times what gives us that? Well, it's clearly the binomial. And again, to ensure that we have the principal square root, we will include that binomial in absolute value signs. The square root of negative 144 is not possible under the real number system. We can't break this down into a number times itself. In other words, 2 of the same numbers multiplied together. You might be thinking negative 12 times 12 would give us a negative 144, but the numbers aren't the same. And even if we pulled off the negative and said, but negative 1 times 12, we still don't have the pair and everything cleared underneath the radical. So here we would say that the principal square root does not exist. And this last one asking us for m to the 30th power, what times what would give us m to the 30th? We want the same number, and if we had m to the 15th and squared, if you remember your exponential rules, m to the 15th times m to the 15th, we add our exponential powers together. That would give us our m to the 30th. So the principal square root here would be m to the 15th power. And because we have a number raised to an odd power, there is a possibility that this could be negative. So to ensure we have the principal root, we will include the absolute value signs for this.